Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of pgMustard, and this is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we talking about today?
Hi Michael, let's talk about configuration basics. We've it's hard to cover them deeply enough for 30 minutes episode, but let's try to talk about some principles and maybe some pieces of advice for new people or for non-database experts or for developers and so on, right?
Yeah, exactly. This has been something I've been hoping to cover for a while, and we got a request for it last week, so I'm excited to. There's a bunch of things that I seem to think are sensible to change pretty much everywhere. Some cloud providers do some of this for people, so maybe it's not so much of an issue these days. But there are so many things that I think even just a basic overview could help people with that I'm keen to make sure we give people a few resources they can go to check in future, but also some probably sensible things to change even from the outset.
Right, and the original request was about where to start, how to start configuring fresh Postgres. But fresh Postgres these days means very different things. It's not only, of course, first of all, different cloud providers, they have different defaults, they adjust defaults. But not only that, if you, for example, check the one of the most famous settings of Postgres, controlling the size of the buffer pool, it's called shared buffers. And if you check the default of it, it's quite uncertain even in documentation. It says 128 megabytes, yep. I think, yes, megabytes. But it's not real default. Real default is 8 megabytes, megabytes. But packages, like for Ubuntu or for Red Hat, they adjusted. So there are several layers of defaults, and of course, if you get Postgres from some cloud provider, for you, the uppermost default layer is the most important because this is what you will get. And they usually, of course, choose 25% of memory for shared buffers as like kind of golden rule. Maybe not correct term here, but usually so. And
actually, before we move on from that, I think shared buffers is a great place to start. I think it highlights a few things, or a few themes, and in those themes we've got things like, by default, a lot of these settings are quite conservative, and they were set quite a long time ago. The team behind Postgres seemed to be keen to keep them on the lower side and let people increase them, but some of them have got so low and so old that it's kind of silly at this point with and this feels like a good example. But the 25% advice, I think that's in the docs to probably bump it up to 25%.
It's not perfect usually. Of course, the perfect value depends on workload and database, and like it's hard to determine the perfect. But 25% is good enough. It's like a 80-20 rule.
It feels like a really sensible place to start, except when I read a really good thread by Andres Freund. I'll share it in the notes.
I must warn you, let's not dive too much into details, because we can discuss shared buffers for 30 minutes easily. And I did a lot of experiments. I can tell you how I lost several $1,000s for experimenting to get a flat curve and understand that experiment was bad and that I paid it out of my pocket and so on.
But I think this is kind of the point, right? Like, I kind of wanted to say that experts will, if you read up on it, if you go down a rabbit hole of advice, you can find arguments to increase it, you can find arguments to decrease it, and that will be true of so many of these settings. But I think shared buffers is like one of the most controversial. But I do think it is good advice to start.
Sorry for interrupting, but if you're expert, of course you should choose 80%. But you should do it very, very carefully with a lot of additional steps. But I agree with you, it's good start, and let me provide a couple of thoughts regarding shared buffers. First of all, default is terribly low, even that one which is configured by packages. 128 and so on. Postgres isn't shipped with any analysis of resources, so it's always some hard-coded values, and when you install it, nobody except you will accept cloud options, of course. So if you install Postgres yourself on some machine, during installation, it doesn't analyze how many gigabytes of memory you have, so it will just put some default like this 128 megabytes. And I call it like most defaults in Postgres related to performance are very, very conservative. It's like very, very outdated, very, very conservative. You need to tune a lot to make it in a good to be in a good shape. But there are a couple of configurator like tools, online tools. They are quite simple. They are just heuristic-based tools. One is on like the Apart UA, some Ukrainian engineer, and it's very popular. It's even mentioned in some books. I saw it, and another from Cybertech. Cybertech maybe slightly more advanced, but basically they follow this 80-20 rule. And if you just use them, you are good enough already. And of course, shared buffers is covered there definitely. For OLTP and web apps following 25%, I'm quite sure. But defaults, if you don't do it, this like I recently tweeted about it. This is I call it Postgres for teapots, because you can have a smart teapot and install Postgres there, and even there probably you would like to configure it, because even if you take Raspberry Pi. For current one, modern, you will get, for example, 8 gigabytes of memory, and still you would like to have 2 gigabytes of shared buffers. Only the very first version had like half a gigabyte where you could use this default. And there is a problem on the other hand. Second thought, there is a problem on the other hand. I think in a few years. The bigger Postgres setups will already experience the problem of reaching maximum. Maximum for shared buffers, we discussed yesterday on Twitter as well. Maximum for shared buffers is 8 terabytes. But there are already instances on AWS which have 24 terabytes. So in several years, we will have instances available on cloud which where you will not be able to apply rule 25%. So it's interesting.
Let's get
on
back
both sides.
It's fascinating. I'm thinking let's go back to some other things that people probably like definitely want to do. I still see quite a few people that don't have, for example, pgstat statements running. That feels like, to me, really sensible. Like extensions that you need, they're defined in the config file. I don't know if you count those as config things. But for me, that gives so much extra benefit for so little overhead that I'm a little bit surprised it isn't on by default.
Yeah, but it's not about configuration. Well, you can consider it roughly as configuration as well. And there is consensus among Postgres experts that pgstat statements should be enabled by default. I wonder, like maybe it should be already in core, right? And maybe installed by default unless you say, no, I don't want it. I never saw any heavily loaded system which would be considered like, no, we don't want pgstat statements. Usually we always wanted this extension. And this extension brings several interesting knobs as well. Well, we forgot to say that there are so many knobs, more than 350. And do you know that you can add your own knobs? Like custom user.
I didn't realize that, no.
Yeah, the knob system in Postgres is called GUC. It's like Grand Unified Configuration, if I'm not mistaken, like Grand Unified. And it's actually quite powerful in terms of like you can apply it at various levels. So you can apply it system-wide using configuration file or alter system with reloading of configuration. Or you can apply it at database level, at user level, so in session, for example, in transaction if you use set local. So there are many ways, and you can use your own variables if you just use namespaces. So something dot something, blah 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 dot my variable equals something. And sometimes I used it. But here we talk about configuration for what? For performance, or like what are our goals, first of all?
Probably should have got that in up front. I was thinking if I'm I think the person who was asking about setting up a new server was onto something. If somebody has been given this task and they want, to make sure they've covered at least the basics, what can we point them at? Like, can we point them in a few directions? I think that some of these tools like the tools you mentioned, I don't think they point out some newer things. So for example, I see quite a lot of people with maybe mixed workloads running into quite a lot of overhead with just-in-time compilation, for example. That got turned on by default in Postgres 12, which is only a few years ago. So it's some of these things haven't kind of had time to catch that kind of thing. So I wanted to mention that possibly if you're running a OLTP workload or transactional, you probably could get away with just turning JIT off and then maybe coming back and tuning it later. Or if you want to tune it, maybe increasing there's a cost parameter, but turning it off for me feels like a really sensible first step if you're not planning to run like huge analytical stuff.
Yeah, there are many such pieces of advice, and of course in OLTP I also turn off just-in-time compilation. And unfortunately, I'm checking these tools. I recommended pgTune and Leopard in UA, and also Cybertech. At least on the first one, I don't see just in time, and I think it's just lagging, right? And I remember there's another, like there are also very good resources. One is PostgreSQL which is kind of your new interface to configuration options for Postgres.
The advice in that is based on annotated.conf, and that's
exactly, this
from
is
Postgres 10. But that's
exactly.
Postgres 10.
Unfortunately, it was maintained by George Berkus, who was in the core team but left to work on with Kubernetes project, and he like shifted his areas of interests. And unfortunately, this project is left unmaintained for a while. I'm not sure. I saw some messages. Probably it will be like resurrected. I hope it will, because it was very good. Yeah,
I agree.
It's very good. Maybe I'm mistaken, actually. But it was so good. It provided a lot of insights, like additional insights from practice and like compiling everything. Actually, PostgreSQL.nf gets information from there as well. But for new knobs like just-in-time, no. Right. So we will not be able to mention all performance-related tuning actions during half an hour, but I would like to remind about principles. First of all, these tools, which are heuristic-based, they are good enough in 80% of cases. And if you actually consider the idea that sometimes poorly written SQL query affects us much more than poorly tuned shared buffers, those 80% probably become 95%. So, I mean, you can fine-tune more and more, and there are many things to tune, of course. But maybe you should start from this 80-90 tool, then focus on query optimization, and then iteratively approach better shape. That being said, of course, new approaches like AI-based auto-tune, here worth mentioning, right? Auto-tune, I think they are good only if you have a lot of nodes, like a lot of nodes. For example, I remember, I think somebody from China, maybe Alibaba, maybe no, somebody reported they had 10,000 instances and they save like 5% of costs applying AI to tune Postgres configuration. And believe me, I spent some couple of years in this area. My company is called Postgres.ai, and I definitely considered working in this area until I realized that optimization of queries is usually, not in all cases, but usually a more important topic. Of course, if you're a cloud provider, you cannot optimize queries directly. But this is my criticism about cloud providers. You could provide more tools like visualization tools, more helper tools, index advisors, and so on to your customers. I think there is a lot of things to do here for cloud providers.
I see some cloud providers not even doing the absolute basics though. Like some of them are doing sensible things, and maybe they're doing the absolute first level, like shared buffers, but a lot of them don't change work mem. A lot of them don't even change random page cost. Or a few that I've seen.
Work mem is tricky. The problem with work mem is that you cannot calculate how much you need. Usually, in really loaded systems, we are over-provisioned. So if you take max connections, and if you take, for example, work mem, you cannot just multiply and say, okay, this is how much memory will be needed by my backends. The problem is that each backend can consume multiple times up to work mem. But in reality, they don't reach it. They consume multiple times, but only portion of work mem.
Yep.
And so if you follow the rules, if you want to be very conservative, avoid out of memory, OM killer and so on, you will be very using your resources not well enough. So many people end up over provisioning consciously or unconsciously, and of course, if workload changes, there is risk to consume a lot of memory. So work mem is tricky. You cannot recommend everyone, raise your work mem, you will be good, because there is also max connections, and this topic directly related to the lack of connection pooler inside Postgres. It's a big problem, right? So we need to think about connection pooler and then how many max connections we need to use.
I think that's max connections is a great point. By the way, work mem, I do think there is sensible advice. I think 4 megabytes, even if you're being really cautious, 4 megabytes, I think is too low.
We absolutely agree. Yeah.
But like a lot of the cloud providers aren't even bumping it up to something also conservative like 16 megabytes. Or so it's 4 times more. You'd be surprised how much of a difference that can make even in OLTP systems sometimes. That's the kind of thing I'm thinking might be helpful to people out there. Like what might be a more sensible default for some of these providers. That's one example. I've seen some modern, like people that have only launched clouds in the last few years still have random page cost as 4, which is a setting that was designed for kind of spinning dit. Like it's not SSD friendly. Like if you were designing that now, I think even a setting of like 2 or 1.5 would be quite conservative. So like these are the kind of settings that I'm seeing in the wild that I don't understand why they're still the defaults.
I also don't understand. They say, okay, we still have a lot of magnetic disks, but new systems don't have them. Most of new systems where you need the defaults. All the systems already configured. Forget about them.
Two things. One, old settings are already configured. That's a really good point. But 2, if only a small percentage have these magnetic disks, why can't they be the ones that have to change the setting instead of everybody else on the SSDs? That's what I don't understand.
There is a big lag in adoption and changes of defaults, and each time defaults are changed, I have a bottle of champagne to open.
Yeah.
For example, recently log checkpoint was enabled. Like logging, it's insanely like let's produce less of logging, but you cannot see issues, and issues come and you don't have logs, and like, of course, like every if you want to cover more than these tools covering. By the way, I'm checking back to work mem. I see that Leopard. Leopard in UA,
pgTune.
Leopard. It recommends for web applications and OLTP. It recommends only 14 megabytes. It's quite low, but Cybertech they do 64 megabytes, which is already good, much better. But I need to check. Max connections is 100 only. Of course, if you increase max connections, you will see work mem dropping, I guess. Yeah. But
actually, Max, can I just make sure we cover max connections quickly? Because I think this is one where some cloud providers are doing the opposite. I think they're going too far. Like I think on RDS, I've seen really, really high max connections by default. and I think Heroku as well.
Well, in LTP situation, it does make sense to have more than number of cores times like 2 or 3 connections, because except cases when they have like weird locking pattern or something. It's usually if you reach already a number of cores in terms of max connections, in terms of active backends, it's already probably you have slowed down already in the performance degradation. But we can discuss a lot of things here, right? Let's talk about principles. So we have these tools, and I think Cybertech is covering more things. It doesn't cover log underscore settings, which I recommend to. I usually recommend to use quiet, like everything on, almost everything. Of course, I don't recommend logging all queries, but I definitely recommend logging all AutoVacuum behavior, checkpointer behavior, everything like that.
DDL?
DDL, yeah, it's for audit.
I think that surprises. Yeah, but that surprises. But it surprises some beginners. I see it come up quite often in Slack and things that they don't realize that you can't check a table to see, or you can't check when an index was created, for example. Like people are surprised by that by default. So I think enabling those kinds of settings can really help UX wise.
Yeah, I agree. And also, of course, like memory-related, connections-related settings are very important for Planner. Random patch cost should be close to 1 or maybe 1. Otherwise, you will be getting a lot of sex counts unexpectedly in some complex queries. Also, checkpointer behavior. 1 gigabyte is not enough on modern hardware usually. 1 gigabyte means that if I'm not mistaken, it divided by 3 or 2 real size of wall, real distance between two checkpoints. It's like it will be half of megabyte with these defaults, or even 300 megabytes. It's too small. So checkpointer will be your most writing process if you check IOTop. If you can check it, of course.
I think we covered that in more detail.
Yeah, a lot of details, but there are many recommendations. There are many of these annotated, still relevant because many things are quite old. We can discuss a lot of things, but what I wanted also to mention is developer experience, because developers usually spend more time on non-production, right? It makes sense. And non-production quite often has fewer resources, like less. Non-production usually has a smaller size of RAM, fewer vCPUs, fewer cores, like maybe less powerful disks, and so on. And here, like over years, I developed some methodology. And we actually already touched it. Buffers first, IO first, analysis of performance. Maybe like single session, not jumping straight to full-fledged benchmarks, right? You can analyze performance using one connection, query by query, or just one query, and so on. And you can tune it if you focus on IO. The most important settings to have reliable testing, database testing, is the planner settings plus workmem, because workmem is forgot to mention, if you check PG settings, you will see in modern Postgres, you will see more than 300, 350, 360 knobs, and they are organized in categories. And there is a category related to planner behavior, planner settings. And you should take all of those settings from production to your non-production. Plus workmem, because workmem is outside of this category somehow. But workmem also affects the planner behavior. And this is how you can achieve similar behavior of the planner in non-production, even if you have fewer resources. People don't understand sometimes the fact that Postgres doesn't know how many gigabytes you have, how many vCPUs you have, what kind of disks you have. It doesn't know about it anything at all, like zero. And for example, the way we tell Postgres how much RAM we have, even not shared buffers, because shared buffers is a thing which is allocated. If production has a terabyte of memory and non-production has only 64 gigabytes, okay, maybe too big scale. Production has 128, gigabytes, non-production has 16 gigabytes. We still can full Postgres adjusting effective cache size, which is not allocated. And this is how we tell the planner to behave similar to production. Not similar, exactly like production. The only is like planner settings on WorkMem, and also like we have two components, this, and second, what we have in PG setting, PG statistic.
Yeah,
plus rel pages also matter. So,
so if you're talking about principles, right? The first principle is if you want to do good testing in non-production, the settings need to be as similar as possible to production.
Planner settings and WorkMem, not others. Others I don't care. Like,
I personally think it is good practice. Like, if you want to test real behavior, why not set? Like, I think the config should be almost identical. Production. To
sometimes you cannot because you don't have so much memory and so on.
Sure, but that's what I meant. Like, so the principle here is they should be the same, except there's cost implications. So because there's cost implications, what are the trade-offs?
Right. And also you need to be able to adjust your methodology, not to pay too much attention to timing when you tune queries. Like, it's okay to have 2x, 3x, 4x slower execution time, longer index creation time, and so on. And then it's just a matter of like, basically, if you have similar size database, you will have similar behavior of Postgres. If number of rows matches, that's it, right?
Yep.
Like, again, there is detail like rel pages. I like understood it not long ago, because rel pages it's like knowledge about bloat. And if you have a logical copy of database, you have different rel pages, and the planner looks at it definitely in PG class. Rel pages for each table and for each index actually, and it takes into account how many rel pages, so how much various operations would need to be done. And here we come with random page cost, sec page cost, and so on.
Yeah, probably a bit far. Like, we probably don't need to be worrying about that.
So ideal situation
config.
Ideal situation is physically provisioned database, so PG data copied at physical level or from backups with the same physical distribution, same rel pages, same PG statistic, and also the planner settings plus WorkMem. And it doesn't matter how much CPU and how much RAM, what kind of disks you have, then you will have exactly the same plans. Of course, with adjusted timing because resources are smaller and caches are colder and so on.
Yep.
And this is how you can develop much better, in my opinion.
Nice. Any other kind of general? In fact, actually, I had one more kind of for the. I guess we're coming towards the end of this, so one more place to go to for a little bit more information. I really liked. There was quite a long EDB guide that they published on a bunch of these things, starting quite beginner friendly and then moving into some more like advanced things. I thought that was a really good primer, and it doesn't take too long to read, so I'll link that one up as well.
Yeah, also there are some talks I remember, like quite long and like tutorial style, maybe 4 hours. Like it's a huge topic, and I'm constantly learning myself from time to time. Yeah. And but we discussed some principles. There is also maybe the most important principle I usually try to follow in my practice is experiment-based approach.
Yeah.
Any change you want to, like any question you have, go and check. In clouds it's easy, right? Just get an instance and check behavior, run benchmarks if needed. If it's like infra level, like. System level configuration, which is probably not interesting for developers, like auto vacuum behavior or replication behavior. Benchmarks are needed. The planner behavior, no benchmarks, just single session experiment. But experimenting is the best approach to learn and to ensure that we are good to change. To perform the change. That's why, of course, having some environments which are to help you having what if workflow, Like, what if this setting is increased? What if it's decreased? But sometimes you need extra deep knowledge to conduct an experiment, of course.
I've thought of one other. This is like slightly more advanced on the config side, but probably something a lot of people would change up front. So nowadays we have parallelism, and there's some parallelism turned on by default. So I think you get 2 parallel workers, which means you get 3 threads by default at most. So I think that's probably something that if you're doing OLTP stuff, you might want to reduce that, especially if you're on a really tiny instance. And if you're doing analytical stuff, you almost certainly want to increase it. So that feels like a big one, but also one that's relatively tricky to test on a different setup. Like that one does rely on your resources, right? Like how do you advise people do that with a different setup to production?
Well, experiments again, like you just conduct experiments and check. So
with a similar number of cores?
Yeah. Well, in some cases you need to have this like very similar or like exactly same instance, and also worth checking if sometimes like if you have full-fledged benchmarking, if you need to like for most reliable change, you sometimes need single session experiment, sometimes full-fledged benchmark. And in the case of full-fledged benchmarks in cloud, I recommend also developing some small script for micro benchmarks to start with. Checking CPU, RAM, disk, network, that it matches expectations, because sometimes you requested some instance, but you've got different CPU family even sometimes. Even if instance family is the same, CPU is different. Or you have some problematic instance. So it's worth checking before you continue with experimenting itself. So set of micro benchmarks with sysbench and FIO, for example, as bare minimum is good. Just to check CPU, RAM, and disk. By the way, I'm looking at the Cybertech tool. I kind of like it. They propose maximum size 10 gigabyte. It's already like good. Depends on database, of course. And by the way, here I don't agree, but okay. Val compression enabled, which is, I think it should be enabled by default. There are some reports that in some cases it slowed down performance, decreased performance, but in general, in most cases, it's helpful to have it on. But they have just-in-time on. They suggest to have it. I don't know. It's like, I don't agree with this, but I agree with most other suggestions. So I think it's a good tool for 80-20 or 90-10 approach.
Awesome. Anything else you wanted to add before we wrap up?
Experiment better. Experiment more often. Experiments are a really cool thing to learn and to make decisions based on data. So experiment, collect data, experiment, iterate, and so on.
Yeah. Oh, actually, last thing to say is that a lot of these settings don't require a full restart of Postgres. Like you can reload the config. Yeah, some do. So maybe if you're in a rush to get a new instance provisioned and you want to just check which ones do and don't, and don't fret the other ones.
I usually check PostgreSQL core.nf.
Yeah,
I know they pull these data from PG settings, which is quite trustworthy source, right? So
yeah, it's got a really nice interface to show you requires restart, doesn't it?
Right,
I like that a lot.
Exactly. So, for example, maxwell size doesn't require restart, so you can adjust it. And for example, even in some cases, I did a dynamic adjustment for some massive operations, understanding that recovery time in case of failure, like database failure, will be longer. But shared buffers unfortunately requires restart, and it's a big issue in some cases that it requires.
Yeah, exactly. And I think pgstat statements as well.
Shared preload libraries it requires restart, unfortunately.
So those kinds of things, if you can get them in at the beginning, it can be helpful to avoid that restart.
Yeah.
Awesome.
Good.
Well,
we covered actually some details as well. I like it. But I
think we did all right.
But I hope we did good work covering some principles. Right.
Yeah,
principles
between
are
us,
more
we got
important.
there. Thank you. I think you did a good job of doing that.
Thanks.
Thanks, everyone. Cheers, Nikolay. See you next week.
Bye bye.